Welcome to lecture number 4 of physics. Lecture number 4, we're going to study about total internal reflection, critical angle and optic fibers. To begin with, total internal reflection. Okay, what is total internal reflection? Sometimes when the light is moving from a denser medium towards a less dense medium, instead of being refracted, all of the lights are being reflected. Instead of being refracted, they're being reflected. Thus, this phenomena is known as total internal reflection. Total internal reflection occurs when the angle of incidence is greater than the critical angle. What is critical angle? We will study about this in today's lecture. And along it, a total internal reflection occurs when the angle of incidence is greater than the critical angle and the incident material is denser. The incident material is denser than the second material. All right. Now, moving forward, this is total internal reflection. When a light is moving from a denser medium to a less dense medium, instead of being refracted, it is being reflected. Total internal reflection occurs when the angle of incidence is greater than the critical angle and the incident material is denser than the second material. All right. There are always two conditions for total internal reflection, and they are that the angle of incidence, I'll write it in like short forms. Angle of incidence, I represents the incidence, is greater than the critical angle. All right. And the second condition is the incident material is denser than the second material. So basically the same thing will come under the second condition. All right, I'll show you a diagram here. If you can see in this picture, this is a picture. Air is a less dense medium and water is a denser medium. Yes or no? Air is a less dense medium, water is a less denser medium. So here, when the incident ray from the water it's going from a denser medium to a less dense medium, it is being refracted. So the angle of incidence is less than the critical angle. You can see this less than sign is here. This is the critical angle when the angle of incidence is equal to the critical angle. See, so the incidence is equal to the critical angle. This is where the critical angle is being formed, and total internal reflection is being occurred here. So this is the incident ray. Yes, it is being reflected. Yes, because if we're talking about reflection, so when the angle of incidence is equal to the angle of reflection, that means angle of incidence is greater than the critical angle. Angle of incidence is greater than the critical angle, which means total internal reflection is occurring. Okay. Now, moving forward, total internal reflection is used we use total internal reflection. It is used in like real life uses. If we talk about, we use in optical fibers. Okay. And the second use is prisms. For example, let's say periscopes. All right. Prisms. Okay, what are prisms? The prisms I'm talking about here is they're used in variety of optical instruments. They're used in variety of optical instruments, including periscopes, binoculars, telescopes, cameras, all these stuff. They're also used in safety reflectors. If you're going on a highway, you might have seen some safety reflectors. They're used for the bicycles and cars, as well as posts making the side of edge. You can see some post by safety reflectors on the roads which says stop. Some safety reflectors say the speed limit. They're all safety reflectors. All right. What is a periscope? This is a periscope. This is a periscope. Okay, this is a periscope. Periscope is a device that can be used to see over tall objects. It consists of two right angle prisms. One prism is here, another prism is here. Two right angles. You can see one right angle is being formed here, another right angle is being formed here. So it is two right angle prisms. Okay, now after this we move to the next topic, which is critical angle. Critical angle. What is it? Critical angle. What is the critical angle? Okay, as the angle of incidence is increased, the angle of refraction also increases as it gets closer to 90 degree. So when the angle of refraction is exactly 90 degree, the light is refracted along the boundary. So at this point, the angle of incidence is known as the critical angle. Now a diagram here, if it's there, I could show you here. Yeah, see, okay, this is refraction taking place where the angle of incidence is less than the critical angle. Okay, so no total internal reflection, only refraction is happening. Here the angle of incidence is equal to the critical angle. Why is it equal to the critical angle? Because it reaches 90 degree. See, so when it reaches 90 degree, that's when the critical angle is being formed. All right. So when the angle of incidence is greater than the critical angle, you call it as total internal reflection. All right. As the angle of incidence increases, it will eventually surplus the critical angle, and that leads to total internal reflection. Here the angle of incidence, and then the light is being refracted, so angle of incidence is less than the critical angle, so only refraction is taking place. Here the angle of incidence is passing through the boundary, and then it reaches 90 degree. When it reaches 90 degree, that means the angle of incidence is equal to the critical angle. All right. Now, okay, so when we talk about this topic, when the angle of incidence is larger than critical angle, the reflected ray, when it's the refracted ray will then reflect. From refraction it will move to reflection. When will this happen? This will happen when the angle of incidence is larger. When the angle of incidence is larger than the critical angle, then the refracted ray will become reflected. Okay, so you call this process as total internal reflection. Okay, fine. Now total internal reflection has some formulas as well. Okay, now there's a formula, okay, for refractive index. Total internal reflection, critical angle, and they all have some equation and some formula. Okay, now what are they? I will tell you. The critical angle is basically, let's say it as C. Okay, the critical angle of a material is related to the refractive index. Remember, in the last class we were studying about refractive index, and I said N indicates the refractive index. Yeah, the relationship between the two of these, the relationship between the refractive index and the critical angle, there is a equation. What is equation? In the calculator you have to find out the angle, you use the key, which is the sine key. All right, so sine C means the critical angle equals to 1 over n, equals to 1 over n. Here sine C means the critical angle. In order to find the critical angle, you divide 1 divided by n. It is the refractive index. N is the refractive index. N is the refractive index. Okay, this can be also rearranged. How will you rearrange it? You bring the n as the subject. N is equals to 1 over sine C. All right, so in some questions, if you have the critical angle given, if you have, 1 will always be there. So and they ask you to find the refractive index. Okay, in some questions, if they ask you to find the refractive index, you use the formula 1 over sine C. In the question, if they're asking you to find the angle, then you do 1 over n, which is the n is the refractive index, which will be given to you in the question. So this equation also shows that the refractive index of a material is smaller than the critical angle. This refractive index of a material is smaller than the critical angle. All right, now since we have since we talked about optical fibers, we're going to learn about optical fibers. It's there in the physics syllabus as well. One thing I forgot to tell you in this is the critical angle. When the light rays are inside a material and they have a high refractive index, what do they have? They have a high refractive index. They are more likely to be totally internally reflected. Okay, which means they have more chances of total internal reflections. They have more chances of TIR, total internal reflection. Okay, now optical fibers, this is in your syllabus. You have to talk about the uses of this as well. Optical fibers. Okay, optical fibers, total internal reflection is used to reflect light. Okay, it is used to reflect light along the optical fibers. They can be used for 3 things. One is communication. Okay, the second is endoscopes. And third one is decorative lamps. You might have seen lamps. Okay, you use it in bedrooms or decorating stuff. All right, I will show you a diagram for total internal reflection. This is how total internal reflection takes place in optical fibers. Okay, this blue line, this thing is the optical fiber, and this is the total internal reflection taking place. Light traveling down an optical fiber is totally internally reflected as it hits the edge of the fiber. This is one edge of the fiber, this is another edge of the fiber, this is one edge of the fiber, this is one edge of the fiber, and the light rays are being totally internally reflected. Okay, optical fibers, one use of the optical fibers is that they're also used in medicine. Okay, it's also used in medicine in order to see the human body. Okay, so that's it for today's class. this lecture. See you in the next lecture, inshallah. And questions will be given to you and they will be uploaded as well. Have a great day. Allah Hafiz.